Nick, maybe I should switch to English. So you have,
Yeah.
you don't have the.
My Turkish are terrible.
Okay.
So.
Nick is. We have been working with Nick on agri PV projects. His company Brite Solar is one of the very important companies in Europe. So he has several applications, commercial ones, and also some research size systems. He has systems established in Greece as well as in Northern Europe, in Netherlands. So he will give us his experience and his achievements and applications. Okay, go ahead.
Okay, thank you, Rashid. I will talk about why agrivoltaics is important, and I will present to you a little bit of different approach than what you heard from the previous two speakers. In the previous two speakers, most of the applications are done with conventional panels. So conventional panels are completely dark, and they affect the plants, and no farmer will accept the installation of agrivoltaics if the yield of the farming is affected negatively. And in many tries, for many crops, this is the case. So we decided to change that paradigm with something different. So what the agrivoltaics is trying to solve is the nexus of food production versus water usage and energy. Right now, agriculture consumes 70% of all water globally and 14% of energy. The United Nations project that the population will increase to 9.7 billion by 2050. In order to feed this many people, we have to increase food production by 80 to 100%. This cannot be done with conventional means because 70% of water is consumed by agriculture. 80% increase, there's not going to be any water for people to drink. So what we need to do is we need to use technology, and the most promising technology is greenhouse farming because it increases the yield of production by 10 times and uses 10 times less water. However, nothing comes for free, as you very well know, so the penalty is energy use. It uses 10 times more energy. The question is, can we get this energy from renewable sources so that the cost is very, very low? The effects of climate change on agriculture for the 14% of energy they're using in terms of temperatures, higher temperatures, shift in regional variability, too hot in many regions to cultivate, and one most important thing that people don't think about, the bee population is decreasing. You may think, okay, why the bees are important to agriculture? They're very important because most plants pollinate by the bees going from plant to plant. So the bee population is very important to maintaining high agricultural production, longer growing season, and of course the extreme weather is causing many problems in the yield of agricultural production. It's happening today. I mean, a couple of years ago, the French wine production ravaged by devastating frost. Small stone fruit crop in 30 years. These are all frontline publications concerning agriculture and the effect of adverse weather. So controlled environment agriculture is the solution. Greenhouses, complete control of the environment, light temperature, humidity, and CO2 concentration, 10x yield, 1/10 of water, 10 times more energy. Agrivoltaics is crop coverings. They provide protection for the crops, birds, hail, wind, frost, heat, precision watering, because you can water whenever you need at the quantity you need, shade if you need to shade the plants, and you can expect plus or minus 20% yield increase at 20% reduction in water usage. Benefits come, of course, with the price because the energy usage in greenhouses, as I said, is 10 times more. So in agrivoltaics, we essentially try to integrate photovoltaics into an agricultural production. And the way we do it in our place is we essentially use glass that is transparent and at the same time it produces energy. So it's a transparent solar panel. And we offer the ability to modify the transparency based on the plants or the crops under the panel, because not all plants require the same amount of light in order to grow. Tomatoes, for example, peppers, cucumbers require a lot of light. If you are doing blueberries or avocados, the amount of light is less. Therefore, we can install different transparency panels for different crops. The transparency is inversely analogous to the power of the panel. The more transparent the panel, the less power. The less transparent the panel, the more power. This is 80% transparent, is good for tomatoes. We also have discovered a nanomaterial that when it's coated on the panel, it absorbs UV light, which is useless for plants and solar cells, and downshifts it to the red region of the visible spectrum in the 600 to 650 nanometer region where the plants photosynthesize. So we take useless light and we make it useful light for the plants. This is the effect. This is a coated piece of glass with our material, and behind it is a UV light. So when the UV light is off, the glass looks like normal glass. But when the UV light comes on, the glass becomes distinctly red. Uniform shading is very critical to uniform plant growth, because in a farm, you don't want some plants to be growing more than other plants. You want a uniform growth of the plants. The current technology that the previous speaker showed you looks like this one on the right. Our technology is on the left. This is an actual installation in Holland for blueberries that uses transparent panels and at the same time does water management. As you see at the end of the installation is at an angle, and at the end of the installation there's a gutter system that collects the rainwater, takes it to the end of each row, and through a central pipe takes it to a storage facility where the water can be stored, and then the farmer uses as much water he needs at the time he needs to water the plants. So who needs agrivoltaics? The governments need it because they can reduce disaster payments, insurance payments to the farmers, because now the plants are protected. The farmers, because they have crop security, a second revenue stream, they produce and sell energy or use energy they produce, and of course increased yields and profits from the crops. And of course everyone, because healthy produce at reasonable prices, decrease reliance on fossil fuels, and therefore climate impact. This is probably the first solar greenhouse done with our panel, and this is the first time a negative CO2 footprint per kilogram of crop produce is reported in agriculture. This one is done with the largest winemaker in Greece next to a vineyard. It produces grapes for wine, and then we have minus 15.78 kilograms of CO2 per kilogram of grapes produced, which is a very significant result, and the only reason this result can be produced is because we are using solar energy to power the greenhouse. This is the dashboard that shows you the energy production of the greenhouse. We monitor this one in real time. The greenhouse is energy autonomous, and it has excess energy, in fact, that feeds the waste treatment plant of the winery. These are pilots for Blueberries. Again, they are done in Holland. And now we are doing tall pilots, 3.7 meters high, for trees, for pears and apples. We have also data that shows for different blueberry kinds, different blueberry varieties, what is the impact of the solar panels and based on the transparency of the panels. You see that the less transparent the panel, the less yield. The more transparent the panel, the more yield. And we found out that in this case, a transparency between 40 and 50% will deliver the best yield, and this is better than the open field without any disaster happening. If, of course, there is a disaster, the open field will yield very low, but this is comparison under normal conditions in a country where there's not a lot of light, like Holland. These are some agrivoltaic, it's not very inclusive, but players. Now, there are incentives for installing agrivoltaics. In Europe, the fertile agricultural land, like in Turkey, cannot be used for PV, but it can be used for dual use. In Japan, agricultural land cannot be used for PV. In the US, especially in Massachusetts and New Jersey, there is a new law that gives an additional premium to the feed-in tariff, the sale of electric energy, if it is used in a dual-use scenario for agriculture and solar production. And this is an example of what can be a dramatic effect of agrivoltaics. And I tried to make it really dramatic. So I took the grape cultivation in the EU. There are 3,134,380 hectares of vineyards in the EU. If you assume that 50% you install agrivoltaics only over grapes, then the energy production will be 1,057,000 gigawatt hours per year. That will reduce CO2 emissions by 677 million tons, and the value of the energy sale will be 42 billion plus. So by using agrivoltaics in a dual sense, in a dual use of land, we will benefit both the farmer, the environment, the government, and the end consumer. Thank you.
Thank you, Nick. Thank you very much.